Um, Today we're going to talk about learning goal. The learning goal for today is identifying and being able to use the angle addition postulate, the segment addition postulate, and the linear pair postulate. Again, we're still working with the GC09 standard, proving theorems about lines and angles. Okay, so the first one is the linear pair postulate, and it states that if two angles form a linear pair, then the angles are supplementary. Okay, well, we know that a line means 180 degrees. Okay, so the linear pair postulate says that if two angles form a linear pair, then the angles are supplementary. Okay, well, if we recall what a linear pair means, right? A linear pair means that two adjacent angles, there are two adjacent angles that have non-common sides that form a line. Okay, and then if we go back to what supplementary angles mean two angles with a sum of 180 degrees. Okay, so a linear pair postulate means that if two angles form a linear pair, then the angles are supplementary, because the definition of supplementary are two angles with a sum of 180 degrees. And linear pair means two angles that with non-common sides that form a straight line. And a straight line means 180 degrees. So we can just keep going in circles here, but it should make sense to you that if angle 1 and angle 2, if angle 2 and angle 1 are a linear pair, then angle 2 plus angle 1 equals 180 degrees. That's all it simply states, that if two angles form a linear pair, then the angles are supplementary. That's all it states. Okay? The segment addition postulate. If point B is on segment AC and between points A and C, then the distance between A and B plus the distance between B and C equals the distance between A and C. Okay, so the segment addition postulate simply states that, let's get my highlighter here, that if we have this distance here, that this distance plus this distance equals, let's pick a pink, equals this distance here. And that kind of makes sense, right? So if we're not given any numbers, we can simply use that segment addition postulate and say that the distance from A to B plus the distance from B to C equals the distance from A to C. And if it was longer, then we could keep going. We could say from A to B, and B to C, and C to D, and D to E, and E to F, and F to G equals A to G. So we could keep going. We could say the distance between A to B and plus the distance between B to C plus the distance between C to D plus the distance between E to D or D to E plus the distance between E to F plus the distance between F to G equals the distance between A to G. Okay. If you have numbers or expressions, I would suggest that you write your equation out and then you fill in what you know. Okay, so if we're told that the distance between A to B is x and the distance between B to C is x plus 2 and the distance between A to C is 7, okay, then we can simply fill in our expressions. So the distance between A to B is x, and the distance between B to C is x plus 2, and then the distance between A to C would be 7. And then we would combine our like terms, so we have 2x plus 2 equals 7, and subtract 2 from each side, and we would get that 2x equals 5. And to solve for x, you would divide each side by 2, and you would get x equals 2.5 or 2.5. Okay, so the distance between A to B is 2.5 or 2 5/10, and the distance between B to C would be x plus 2 or 2.5 plus 2, which is a total distance of 4.5 or 4 5/10. And then if we added 2.5 and 4.5 together, we get 7. So we could verify that 2 5/10 plus 4 5/10 actually equals 7. And when you do that, you can see that you are completely correct. Okay, and then the angle addition postulate. If point D lies in the interior of angle ABC, so I've drawn my picture wrong. So if I have, oh, sorry about that. If I've got A, B, C, and that we're told that point D lies on the interior, then the measure of angle ABD, so the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So we use these M's outside here, and they indicate the measure of an angle. Okay, they don't indicate slope here, they indicate the measure of the angle. And let's just talk about that for a second. Now, what we're trying to say is that this angle here plus this angle here equals this entire angle. That makes sense. Okay, so if you're given that this angle here is 25 degrees, if we're given that this angle here is 25 degrees and this angle here is 30 degrees, then we can simply say that the measure of angle ABC is 30 degrees plus 25 degrees would be a total of 55 degrees. And when we're talking about the measure of angles, you got to actually put this degree symbol here because angles are measured in degrees. So you need that little degree symbol to indicate that you understand what the measure of the angles are. Okay, so the M in front means the measure of, and then we just simply follow the same thing, those orders of operation, and we're solving. If we're given variables, you're solving for that variable. You've got to isolate the variable term and then solve. Or if you're given just straight numbers, you can simply just add your numbers together.